No, ma'am.
Okay.
What is higher component? Okay.
हेलो क्या हुआ लास्ट क्लास नहीं आई
हाँ actually मेरा
अच्छा।
आएगा चेकअप का so I don't need.
This Mary is allowed in your school? What do you mean by this? It's not allowed in many schools.
Yeah, but in our school no one checks. But like
Did you have time to revise? What? Did you revise or no? We have started with sound, the chapter on sound. So we have seen that what type of waves are these? Transverse or longitudinal? What is sound? Is it longitudinal or is it transverse? Okay, we both. It's either this or that. I'm giving you a choice. Are you sure? Longitudinal, yes. Okay, why do we say longitudinal? Because of the compressions and rarefactions, they are going in the same direction as the propagation of the sound. So the person who is the place where the sound is created and the place where the sound is being received, okay, it moves in the same direction and it moves in the form of compression, rarefactions, compression parallel to the propagation of the wave. Okay. So what happens in compressions? All the molecules are coming together. So what is the density line? High or low? Density is very high because the molecules have all come together. See the diagram here, this diagram. Here was a diagram.
okay.
So what happens? It's all coming together. So high pressure and high density. What happens in rarefaction?
Low pressure.
Low pressure. Okay, so if you are going to represent this in the form of a wave, you will have a crest and you will have a trough. You will have a crest and you will have a trough. Okay, so what is one wave? Starting from the median, you will have a crest and you will have a trough and back again to the median. This is one wave. Or you can say the distance between two crests, between two hills, two crests, or between the two troughs, that is also one wavelength. And we have also seen what is wavelength, frequency, time period. See your definitions. Okay. And we have also done one very important formula. Speed is equal to distance upon time. Yes. So
Wavelength into frequency.
yeah, sound we have seen. Speed is equal to distance upon time. Okay. Speed is nothing but velocity. So we can say it is nothing but distance upon time. So speed is v. You can say like velocity. Distance is what? The distance between. Now we are talking about a wavelength. It's either between here and here, or we can also talk between these two. Okay, crest, which is known as a wavelength. So the distance covered is this thing. It is a wavelength upon time. Correct? So we say that v, which is speed, is equal to lambda. Instead of writing by t, I can put it as 1 upon t.
T.
Correct? It is 1 upon t. But what do we know? 1 upon t is nothing but nu, which is nothing but the frequency. Right? So we can say v is equal to lambda nu, or you can also write it as nu lambda. V is equal to nu lambda. Have you written it down?
What derivation coming inside?
Yes, it's a very simple definition. Okay, write it down. Speed of sound. Speed of sound is distance upon time. For speed, we will write it as v, because v shows actually velocity. Distance upon time. This lambda shows wavelength. For you, I'm telling you, because you missed last class. What is this lambda? Lambda is wavelength. I'll get another pen. Okay, so we have lambda, which is wavelength, and we also have this
What it is called?
wavelength. Lambda. It is called lambda. It's a Greek alphabet. Like alpha, beta, gamma. Lambda is also a Greek alphabet. Okay, and nu is nothing but the frequency. Got it? I want you to write down one. Speed is nothing but wavelength into frequency. Now the speed of sound remains almost the same for all frequencies. So here frequencies, the speed basically remains the same, right? In given medium under the same physical conditions. So approximately when you're talking about the speed of sound, it is 340, 344, etc., etc. There are two factors. One is with increase of temperature. So sometimes what happens is when the temperature increases, the speed of sound also increases. Very little. For example, there is one thing, get these noted down. Okay, the speed of sound at 0 degrees is 0 degrees Celsius is 330 meters per second. Okay, 330, yeah. 331, 330 at 0 degrees. And if you keep on increasing the temperature at 22 degrees Celsius, it's around 344 meters per second. So what does it tell us? As the temperature is increasing at various temperatures. They have just given one example. For example, they have given. That's all. Okay. So on an average, we usually take it as 340, unless they actually specify in the sums. Okay. So basically, this is what we are talking. As the temperature increases, what does it tell us? The speed of the sound is also increasing. Right? Another thing that if you look at this particular table, we know that sound requires a material media to get propagated. That means it requires either air or it requires water, liquid, or even a solid. But the speed of sound in various medium is not the same. Did you see this? That particular table must also be there. There's a table there on which
Yeah,
page is it?
aluminium.
Yes, aluminium, nickel, etc. So we will see. We don't have to learn everything, but we'll just talk about the medium. So in medium, like you have got a solid, liquid, and a gas. Just take down this only for you to understand. Okay, so substance like let us say you're taking aluminium. And what is the speed here? It is 6,420 meters per second. Right? But when you look at something like water, distilled water or whatever it is, okay, the speed is 1498, approximately 1500 meters per second. And if you look at gas like air, it is 346. Okay, so this is once again telling us that the speed of sound is not the same in all the medium. So it begins to vary. Just note down only these three figures, there's nothing else that you need to know. So where does sound travel the fastest? Travels the fastest in solids. Next, we'll also talk about echo. Have you heard of an echo? You must have gone to some matharon or some.
Yeah,
hill
that
station.
voice comes again.
It gets repeated. Okay. Suppose you are standing at a particular point. Let us say this is your echo point, and you are clapping your hands. So what happens? The sound travels to a certain extent, and then it comes back again to you. So what is it?
Yeah.
It is nothing but a rebound of the sound. But does it take place in a classroom?
No,
It is
I know.
Does it take place here? No, right now. No. Why did you say it might take place?
If the class is empty and lights on.
Maybe, probably. Suppose you go to a very huge go down, and it's a big
Parking
parking
lot.
lot. Sometimes it can get
Yeah, exactly.
tunnels.
Tunnels will be also.
Not necessary. It will not be there. It will not be. Why? Because it needs a surface to bounce back. Suppose you are taking a tennis ball. Okay, you have to hit it at a wall so that it comes back again. So the same thing for sound. Sound has to travel to some place and rebound at another surface. That is when it is going to come back. So what happens in our ear is, for us to hear this distinct echo, you must have a gap of at least about 0.1 second. What does that mean? That means you will be able to hear an echo after 0.1 second. So let us see basically what happens here. Are you having reflection of sound? Are you having echo there?
Yeah.
Okay. So we'll see what is happening is, let us say you are talking about the speed of sound is 344 meters per second. Here they have given us 346. Obviously, 344 is at 22 degrees Celsius. This is per second. So what does it mean? That in 1 second, it is traveling a distance of 344 meters. Correct? In 0.1 second, what is the distance it travels? 34.4 meters. Correct? What does it tell us? That the sound has to go, strike the surface and come back in 0.1 second. Did you understand? So the distance between here and here has to be half of this. So how much is half of this? 34.4 divided by 2. How much is that? 70. Yes. So that's basically about 17.2 meters. So this tells us that for an echo to be felt or to be heard, the distance between the person who is clapping his hand and the other object has to be a distance of 17.2 meters minimum. Okay, so that's why this is not 17.2 meters. So if you are having a huge go down with not much of furniture and all that, so when you clap or something of that sort, you will be able to hear an echo. So 17.2 to go from point A to point B. Again from point B, the sound has to come back to the person. So when you add up the two things, the minimum distance is 17.2.
So going, it takes 0.1 and coming, it
No.
takes 0.1.
No.
The whole takes 0.1.
Yes. So you will be able to hear. Okay, you will be able to hear the echo if the ear is able to hear the next sound after 0.1 distance or after 0.1 seconds.
So that would be completed in 0.6.
It's not necessary. We'll do sums to see. Okay. For example, if you are hearing an echo after 2 seconds, what does it tell us? It has taken 1 second to go and it has taken another second to come back. This is the minimum time that needs to be recorded. This is what it says. Okay. So if you see that, come on, take down a couple of points on echo. I'll give you echo. What is an echo? Sound bounces off a solid. the bracket you can write gets reflected. Okay.
Can you repeat it?
The sound bounces off a solid or it gets reflected.
Bounces upon solid arm.
Bounces off a solid and gets reflected. Okay. Which is heard as an echo. The next point. Next point. The sensation of sound persists in our brain for about 0.1 second. Next point. In order to hear an echo, the sound must go to the obstacle and reach back to the person after 0.1 second. Next point. Therefore, the total distance traveled by sound will be how much? 34.4 meters. Total distance traveled by sound is 34.4 meters. And show the working. Why did you get the value of 34.4? Speed of sound is 344 meters per second times 0.1 multiplied by 0.1. Therefore, it comes to 34.4 meters. Last point. Am I too fast? Final point. Okay. Therefore, for hearing distinct echoes, the minimum distance required is 17.2 meters. All of you are having your book, no? See this example, some of you have a person clapped his hand near the cliff and we heard the echo after 5 seconds. It's there? Yeah, we do that for you to understand. Okay. What is the distance of the cliff from the person? If the speed of sound is taken as 346 meters per second. Okay. 3, 4, here, they work. Then, so speed of sound, what is given to us, and what is the sound? So here they have given that a person is clapping his hand and he heard the echo after 5 seconds. Did you understand what is happening? We are standing here. What does it tell us? 5 seconds for going and 5 seconds for coming?
No.
Is it 5 seconds for going and 5 seconds for coming? What is it?
5 seconds total.
Total. Okay, when you clap, the sound is going, hitting that thing and coming back. Did you understand? So for the sound to go from here and coming back here, it has taken 5 seconds in total. Okay, so the time taken is how much?
5.
It's 2 seconds.
Okay.
It's 2 seconds.
Either
1 second. Which one are you seeing?
70.
Example 2.
Let it be. I'm just
Yeah.
not here.
That's
It's okay.
example 2 separate.
Well, maybe you are looking at this. I'm giving examples. Maybe you are doing something else.
No, it is example 2.
From volume.
Yeah, volume.
Fine. Whatever it is, you can just substitute it. Okay. Then here, what else are they asking? The speed of sound. Come on, write it down.
Yeah.
The speed of sound. Question is, we have to find out what is the distance of the cliff from the person. Required to find distance of the cliff from the person. The person is standing here on first hill. This is the cliff. Okay. Now they want to find out what is this distance from here to here. What they will do?
What is RT?
Required to find. This is what you have to find. What will you do? What is the formula here? Speed is given, echo time is given. What will you do? Formula. What will be the formula? Speed is equal to distance upon time. Correct? Come on, let's do. Speed is distance upon time. So therefore, distance. We have to find out distance only, no? So distance is equal to what? Speed into time. Correct. So we have speed into time. Speed we already know. That is 346 meters per second. Now time, how much will we take?
5.
Will you take it as 5? Will you take it as 5? What did I tell about time? Time is for the sound to go till there and it has to come back.
2.5.
So take only half of that. Did you understand why? Okay? You should not take it as 5, but you should take only half of it. Because we are talking only about one, the distance is only this, na? If you take 5, that means you are taking double the distance. We don't want double.
If they are given total distance, then we have to do it. Yeah.
No, they are not. They are asking you what is the distance here. Isn't it? They are asking you what is the distance between one cliff and the other. So what will you take it as? You will take it as only half of that. So time here, it will be 5 upon 2. This will be in seconds, suppose.
866.
This is second. So this and 6 will get. Let's cancel. 3, 4, 6. Don't even have to write it as 2.5. 5 by 2 you put and then it gets cancelled out easily. How much is that? 8? 65. Correct. So it is equal to 865. What will be the unit?
Meters.
Meter, remember. Because second and second has got cancelled. Okay. So the distance between one cliff and the other cliff is 865 meters.
What if time is in minutes and what
Convert
is
it.
the standard unit and
Second.
distance to
Meters. Distance is always in meters.
what if it's in kilometer and time is also in
Convert
minutes?
it accordingly. Converting. Suppose for the same thing. Okay, now suppose they have already given you here. Let us say the distance they have given as, instead of giving as 865 meters, they have given something else. Okay, maybe they have given it in, let us say, kilometers. So convert the kilometers into meters. Correct? And suppose they have given the time, let us say, something in minutes. Convert it into seconds. And then you will be able to find, because speed is always given in meters per second. Remember, it is going to be meters and seconds. So either which way you are going to convert it. Got it? Okay. So what is reflection?
865.
Yeah. So when you're talking about reflection of sound, do you remember reflection of light? Come on, you know that. Suppose I'm having a mirror here. Okay. Haven't you learned in the previous standard?
Incident.
Incident ray. This is the reflected ray. Angle of incidence is equal to angle of reflection. So what is happening to sound? When you're hitting it, it is getting reflected, just like you are talking about light. So even sound is also going to be following the same laws as that of light. So suppose you're having sound which is incident on any board. Board is like this. Okay. Suppose you're having a tube here. Let us say this is a tube and you're producing some kind of sound. So the sound is going to go and hit the surface and it is getting bounced back along this path. So if you measure this angle of incidence, you will find that it is equal to the angle of reflection. So even the sound follows the same laws of reflection just as light. Okay. Did you see this particular diagram? Reflection of sound. This diagram, did you see? So you can actually do this experiment. Correct? So what do? We have tubes like this. It's a long plastic tube. So we have two tubes here and we can adjust the angle. Suppose I keep this at 45 degrees and I'm making some sound. Let's say I'm having a watch or something. Okay, making a nice tick-tock sound. Tick, 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 tick. So how do I know? So the other person, he puts his ear here and he keeps on moving it till you get a loud sound. And then you're going to measure this distance, angle here. Okay, so you will find that the angle of incidence is the same as angle of reflection. Make a note of it. Make a note. Angle, sound also follows the laws of reflection just as light. That is, angle of reflection, angle I, is equal to angle R. But now we are talking about sound. Is that okay? Now here we have got uses of multiple reflections. Sometimes when you go to, has anybody gone to Golgumbas? Golgumbas, it's a huge one, it's a tomb which is constructed. Have you gone to Hyderabad, Golconda Fort? No, unfortunately no. So it's constructed in such a way that a person can clap and you can hear multiple such echoes going on. So it is beautifully constructed. Okay. So why it has been constructed is because in those days they had to see the enemies. So the fort is usually built on a hill, and from the hill they can see if there are any enemies who are coming. So the fellow who is standing on the straw, that is the sentry or the guard, he is to clap. So when he claps, he can hear multiple echoes, and that will be a signal saying that their enemies are coming. So that is the way it was constructed. So we are talking about the uses of multiple, look here, in your book you have uses of multiple reflection of sound. So one is that megaphone. You know what is a megaphone? Like how these police people, traffic controllers, they have that megaphone. Right? Suppose they want to announce something. So the sound is going to be reflected in multiple ways. Okay? Multiple reflections are there.
That teachers use in school.
This way, this one? Not a mic?
Some uses that microphone that is like a pulse or something. Some use this.
While teaching in the class? Yeah, obviously, because yeah. Some there may be a small column mic or something of that sort.
No, that huge one, like the on stages.
Okay, proper one. Okay, right. How many kids in your class? How many students?
Usually 40, but 35 are
Oh, that's manageable.
Same.
That's quite manageable. Okay, so we have you gone to a doctor? We have a stethoscope.
Yeah.
So what happens is stethoscope based on the patient's chest. So what happens is it picks up the heartbeat, and that is how it is getting. Okay, so what exactly is happening here? So when you look at the stethoscope, this is how it is, right?
Yes.
Correct? So I'm talking about this tube. So in this tube, the sound is sent, which bounces off like this.
Sound travels in straight line.
It just traveling in straight line. But if it
Like
is
light.
just like light. Here also you see what is happening. It is bouncing off, it is following the laws of reflection, angle of incidence, angle of reflection, and that is how it is actually receiving. That is, the sound is being picked up by the patient and it is received by the person, that is the doctor who is going to be dealing. So multiple reflections are definitely so much of an advantage. Another thing is, have you seen churches? You must have seen at least from outside. How is it constructed? It is always in a tone. There's a purpose. Why is it so? Because in the earlier days, we did not have mics. And the priest used to stand there and give sermon. His voice had to be heard by everybody across. Okay? And obviously there should be no echo, because if there's an echo, then you cannot hear the priest properly. So it is constructed in such a way that a concave surface, suppose this is a concave surface, and the sound is hitting the surface, what happens is it is getting reflected back. Similarly, if you are talking about another sound which is incident, that is also getting reflected back, such that this is the focus. Did you understand? So imagine the same thing, I'm curving it. So suppose you are having a curved surface like this, and the person is standing here and giving the sermon. The sound waves are traveling all over, it is hitting the roof, and it is coming back at a particular point, so that his sermon and his sound can be heard, okay, properly. Next, we can also see sometimes what happens is this echo is not desirable. Okay, sometimes it can cause a lot of confusion. Suppose, let us say you have gone to that, auditorium, and there is a musical recital or whatever it is. If it is echoing, because it's a huge thing, it is more than 71.4 meters. So we don't want echoes. So if the echo is felt, then you cannot hear the sound properly. So what happens is, if you notice it very carefully, the paneling of the wall, it is usually made up of a thick material. Similarly, the cushions are always made up of velvet. Okay, the curtains are all made up of thick material, such that the stray sound can be absorbed. Okay, if you have gone to a sound recording studio or something of that sort, we usually have a soundproof room, and that room is also made in such a way that it has got sound absorbing material. Okay, so therefore the sound should not be, echo, that is the reverberation of the sound should not be here. So you please learn and put a tick mark in that. None of you are having a textbook. What is it? Uses of multiple reflections of sound, put a tick mark.
There's a room in some part of the world where you cannot hear the sound. Like even from the outside world, you only hear when locked in a room for like
From the outside world, what does it mean?
external sound.
Okay.
And then you
was
can,
a whole single world.
and then you can hear your own heartbeat.
I'm
your own
going.
breathing. Oh, yeah.
What is it?
Meanwhile, you are trapped in a room and there are so much holes in it, it's hexagonal holes, and you have to stay there for at least 1 hour.
Okay.
And you will get more like $1 million. But
Yeah.
no one has survived till 10 minutes because
Right.
in sound cannot reflect only.
Okay. So.
Since you can't hear anything from the external.
So that's why. So
They get disturbances.
where is this?
Radio देखा ना
Somewhere around Switzerland.
Okay, let me just check it out because I have not come across this. Is it a place or they constructed a room?
Constructed a room.
Okay, I will see. Okay, that's not very difficult for us to check out. Okay. Are you okay till now? Okay. Now let us see something about our own range of hearing. Now you will notice that there are different types of sounds, right? You can hear sounds of different frequencies, but our human ears can be picking up only certain range. Whereas the dogs can pick up, if you are having a pet dog, you immediately know that dogs can have a very powerful hearing sensation and they can pick up various frequencies. Suppose the owner is coming somewhere far off, he begins to wag his tail. So we know that their animals, most of the animals are able to pick up various frequencies. But for us, it is from 20 hertz to about 20,000 hertz. Okay. So the range, write it down in your book, range of hearing. 20 hertz. When I say hertz, what are we talking about? Hertz is what? We are talking about frequency. This is a unit of frequency, okay? 220,000 hertz. Okay? Instead of writing 20,000 with so many zeros, I can also write it as kilohertz. What does that K stand for? It stands for kilohertz. So what will be the answer? 20. Very good. So it is 20 kilohertz. Did you understand how? 20,000 hertz upon 1,000. Correct? That is your 20 hertz. 20 kilohertz. So that is the range that we can get. But what happens is, you must have noticed your grandparents, as you become old, what will happen? They will not be able to hear.
Yeah.
Why? Because the frequencies is not picked up by the human ear. It begins to fade. Slowly starts decreasing, just as your eyesight. Okay? So as you become older, obviously the muscles of the eye will also start functioning less. So you will be able to, they'll not be able to pick up the right frequencies. So now what we can do is catch different type of sounds which have got a frequencies here. But bats, do you know about bats? What is a bat? Bats are these are the mammals, right? Which fly around in the night.
Yeah.
Those are the ones which are able to pick up different type of frequencies. Now they are the ones which are nocturnal. That means they eat moths. Correct. In nocturnal, when I use the word nocturnal, it means night. So they eat the moth, they eat the insects. How is it that they are able to catch it? Suppose there is a moth which is flying. So what these bats do is to send ultrasound waves which strikes the moth and it gets back again. So it knows the direction of this insect and then they go and catch it. So even the animals are making use of echo, okay, and they use the ultrasound.
Not bats smell very bad.
Yeah.
Bats smell very bad.
Not their own smell, because if they're present in a cave or something.
No, they doesn't come down. So we.
No, if you are going into a cave where they are there,
Okay.
like for example, Ajanta Ellora caves or something like that, where did you go?
In our society, there are
Manali.
Yeah.
tents.
Manali.
On a tree?
Yes.
Oh, yeah, this was. Oh my God, huge ones. Those are the fruit bats, I think. My God, it's really creepy, no? Which tree is it? Palm. Okay, surprised. Yeah. Right? So you find that each time they are using the ultrasound in order to catch the echo. Right? Did you understand? So what they do? They produce, suppose this is a bat and this is the insect. They are producing the ultrasound. Ultrasound will strike the insect and the sound is coming back again. So the bat is able to make out the movement of the insect and it will go and eat it up. Imagine all this is happening when they are flying. The bat is flying, the insect is also flying. They're all moving on in all directions so quick. So in a matter of fractions of a second, all these things are going to happen. Correct? Okay. Right? Put a tick mark there. I've told you about the bats. Range of hearing we already know. 20 hertz. Below 20 is what is known as infrasound. And more than 20,000 is what is known as ultrasound. Correct? I've used this word ultra. Ultra is more than this. So ultra comes here. And anything less than 20 becomes infra. Just as we are saying infrared radiation, ultraviolet, don't you remember that? Electromagnetic radiation for light also we use ultra, UV light. Okay, that is ultra. So ultra is more than, so also obviously it is going to be more than that. Right? There's another very important application, like for example, you got, let us say,
Ultrasound and infra.
infra.
Oh,
Infra. Infra is less than 20 hertz. Make a note of it. Infrasound is less than 20 hertz and ultrasound is more than 20,000 hertz. Now let us look at huge trawlers, ships. Let us say it is a fishing ship. And this is the sea floor. Correct? The sea floor is not always like this. Sometimes it could have some rocky surface or something of that sort. And what happens is sometimes when the ship is coming closer and closer, there could be a place where the surface is so much that it could collide. Now in the road we can actually see and take a turn if there is an obstacle. But here in this particular case, because it is below the surface of the water, they cannot see. So what are we doing? We are using this ultrasound. So what happens is, this boat or the ship is usually fitted with what is known as a transmitter. Okay, and there's a receiver. This is the receiver. So the transmitter transmits the sound and it hits the surface. And then again, it gets bounced back. So which principle are we using? Sound is going there and coming back. That is nothing but reflection of sound.
Why didn't they use it during that?
Really, they did have, but unfortunately there were a lot of mistakes going on there, and that is why unfortunately it happened. So what is happening here? We are basically using nothing but the reflection of sound, and it is nothing but an echo. Did you understand? Sound going there and coming back. So what are we doing? We are using the time taken for the sound to come back. And we are using speed is equal to distance upon time. We are using the same formula. And from this you can calculate the distance, saying that it is speed into time. Correct? So quick calculation can tell us what is the distance here. Should I take a turn and go away? Have you followed? So that easily comes up on the screen. Now today suppose everything is computerized and you can make up, and it becomes very easy for them to understand. Now speed, should we take it as 344? Because the speed of sound is 344.
But the speed of sound in water is different.
Very good. Speed of sound is now in water. It will not be 346 or 344. Did you understand? Why did I give you those three things? In solid, liquids, and in gases. So 346 or 344 or whatever it is only in air. That is in gas. But this is not water. It is water.
Liquid.
So when you are liquid. So I've given you for water. So when you get a sum like this, you have to use that value. Remember. Only that. Because when we are talking about such type of sums, see here, if you get the diagram, put a tick mark. Okay. Which value will you use? You will use the value. Make a note of it there. Use the value. Speed in water. Sea water is 1531. In the table here, they have given us 1531. See here. Distilled water is different and sea water is different.
Yeah.
Okay, so it is 1531. You have to use that. Yeah.
It's
And if it is
1 minute.
Is echo there in seawater?
This is based on eco only, no?
Like, no,
Yeah,
not
it is.
that. Like randomly the waves and that.
Waves are moving, but the sound is going, striking the surface and coming back. How do you think dolphins and porpoises are able to communicate with each other? It's the principle of reflection of sound. They produce those high-pitched clicking sounds, I believe. That's what I read. So this sound is picked up by another, let us say another pod of dolphins which are swimming back. It comes back again. So it's sound which is striking a surface, coming back again. So they are using this principle of reflection of sound, which is nothing but echo. Have you followed? So what are the points that you must remember? Please write it down. Okay. So this is what is known as SONAR. So write down a couple of points about sonar. SO, sound, navigation, and ranging. sound,
Navigation.
navigation and ranging. Write it in your notebook, please. Okay. I'm just giving you a couple of bullet points because the rest of it is already given there. Uses, first point, uses transmitter and detector. Even in the-
Really detector that.
it detects, but detecting is receiving. It is basically receiving sound waves.
Using.
Uses transmitter. What is transmitter? Transmitter is sending the sound. That is transmitting the sound. And receiving the sound is the receiver.
Now, there's a machine which catches the presence of ghosts. So
Ghost.
yeah, that it
Yeah.
shows green light means there are no ghosts, red light means there are presence
Box
of.
type.
And then, so is that based on this?
So far there is no ghost.
Means that machine checks the aura, no? The means one person who is dead have negative aura. Means aura is like a form of heat that that spreads 3 to 4 feet
Okay.
across
Okay.
our head.
Okay.
So when someone dies, it becomes negative, and when still they are alive, so it is positive. So the how much negative aura is present, it measures. So the more negative, the more signal will be received.
It uses.
So I don't think sound will be involved.
We are talking basically of, let us say, if somebody talks in terms of infrared, yes, I can definitely say. Because infrared photography, most of these wildlife photographers can use. If you are going in the wild and it is dark, how do you know there is a herd of elephants standing there? That's because the mammals radiate heat. Okay? So infrared photography can capture the heat which is radiated. Yes, that is possible, but not for ghosts and all. I don't believe it. Okay? Next one. So you have written what?
Uses
Transmitter
and
and
detector.
detector. Okay, detector you can use or even a receiver. Then uses the technique of echo ranging. Last point, right? Uses to determine the depth of the sea and to find or to detect underwater, iceberg, sunken ships. Right?
To find depth.
Depth
Of
of the
the
sea. Okay. Sunken treasure. Okay. Submarines, etc. Let's take up a sum for this. Have you written sonar? What is SONAR? Sound,
Yes,
navigation,
navigation and ranging.
and range. Okay. Now, I don't know whether it is given in your book there. The ship sends out ultrasound that returns from the seabed and it is
No.
detected after 3.42 seconds. You understand? This is the ship. Now look at this. This is the ship. What is it doing? It is sending ultrasound. So ultrasound waves are going and it is coming up after 3.42 seconds. Like in the, this is your question. You are going to solve the sum. Okay. So what is given? Time. Time between transmission and detection because it is transmitted and then it is getting detected. What is the time given? It is 3.42 seconds. Okay. Another value that they have already given here is the speed of ultrasound in seawater. Remember, this is not fresh water, right? It is seawater. So the speed of ultrasound in seawater is 1531 meters per second. What is required? What should we try? Yeah, we are trying to find out what is the distance of the seabed from the ship.
Multiply.
Yes. So we have to find out the distance. Write down the formula. Distance is equal to speed into time. So distance here is 1531 meters. And time is how much?
3.4.
Half of it.
Oh,
Ah, half of it, because 3.42 seconds is for going and coming. So 3.42 times half. Why did we take only half? Because this is the total time. We require only half the time. So we need to calculate this.
Three six one eight zero one.
How much is it?
361,801.
Divided by 2 unit. After that, it's the final answer. Do. It's the final answer.
Um, 2618.01.
2618, you got it right. Okay.
0.01
So this is in meters or in kilometers?
meters.
Okay, 2618, right? This is correct, 2618. Okay, meters. And if you want to convert it into kilometers, what will it be?
Upon 1,000.
Upon 1,000. So you can also write down the answer as 2.618 kilometers. That means this distance from the seabed to the ship, right, is so many kilometers. Did you understand why we have done divided by half? Remember that. Is that okay? Yeah? Okay. So, most of it we have already finished. Next time, when is the next class? I think day after tomorrow there's a last class that we are going to have.
Friday.
Friday we will have a last class on Friday. You have a maths class?
Yeah.
Maths you have, yes. So after maths class, we will have the science class and that will complete this chapter. We have almost come one or two sums that we do here and structure of the human here that I'll explain. What has happened to this? Got it? Yeah? Okay. I want you, will you be able to read that ship and the sonar? All of you get that book.
Sonar stands for
Stands for read.
sound navigation and range.
Who is reading read?
Sonar stands for sound navigation and ranging. Sonar is a device that works on the reflecting property of sound waves.
So what is the basis? What is the principle here? Based on what? On the reflection of sound. Underline. Sometimes they'll ask you questions like this. What is it based on? So you have to write it is based on reflection of sound.
And it is used to measure depths of oceans, altitudes of places, locate obstacles in the path of submarines, etc.
So what is that? What is that point tell you? Applications. What is the use? What is it used for? Suppose they're asking question says, what is the application of sonar? So you have to tell all these points.
It sends out ultrasonic sound signals and receives the reflected signals. The time gap between the transmission and reception is recorded. The total distance traveled by the
What
sound
is the
waves.
meaning of ultrasound?
Sound more than
Sound
20,000 words.
Yes, it is more than 20,000 hertz.
The total distance traveled by the sound waves in time t is 2d. If d is the distance between the source and the reflector, then d is equal to v in the speed into time upon
Why is it upon to you understood? No?
The time gets
Yes. Okay. Here we are talking about the sound going, hitting the bottom and coming back. Suppose it is 4 seconds. So it is 2 seconds
Yeah,
for going
and 2
and 2
seconds
seconds
for
for coming. So you should take only half of it. That you should remember. Okay? Finish other points. One more.
Anna.
the parts of machines, instruments, etc., which cannot be reached directly at it in a liquid cleaner and are subjected to ultrasound waves. These waves force the dirt particles out of the machines.
So that is another application which is given in the textbook here. They are given it only as a small point. See, there is a, if you get your, people don't use the textbook even in school.
Yeah, we use actually in UP all the volunteers use, so we do.
It's a condensed form, but I prefer that you people use this. Right?
in textbook, I think there's 2 paragraphs.
बहुत बड़ा
It's condensed, that is why I'm
detail
saying. This is all given in each points. Applications of ultrasound. Okay, so what happens is they have given you quite a few things. One use of ultrasound we have seen and this sonar. Second thing is used to clean parts of hard to reach places. For example, a spiral tube or an odd shaped part of an electronic component, etc. So what they see is any object which has got a very funny shape and it needs to be cleaned, that is kept in a cleansing solution, and then you are putting in ultrasound waves. So what happens is the whole thing is getting agitated and therefore it gets cleaned. So that's one of the applications. Second thing is here, for example, to detect the flaw. Is that diagram there? No. Okay. Now let us say this is a huge dam or whatever it is. Okay, and we want to know whether there are any cracks in this particular concrete block. So you can take this concrete block to the factory and either can you break it down to see if there is any flaw. So in such cases, you are going to be using an infra
How would
ultrasound.
you use in build plastic? How would you use it if used to build plastic?
Continue. Okay, so detect a flaw. So what is happening is suppose there is a crack. If at all you are having a sound which is passed through, if there is no problem, the sound will pass through it. But if there is some kind of an obstruction, like for example, if there is a crack or something of that sort, it will hit the surface and come back again. So the moment the sound is coming back, you can pick it up and say, okay, there is some problem with the object. Okay, once again, we are using the concept of reflection of sound for us to understand if there is any flaw with the object. Did you understand? So uses are something. Just show me a book whether they mention everything. Just as a point. To well plastic medical field cleansing of machine parts is what they have given. That's all. Here they have given you 2 other additional points. Okay. Now for welding plastic, read that.
Two plastic surfaces can be welded together subjecting them to ultrasound waves.
Hmm.
In
Basically what happens is when you're subjecting it to ultrasound, it is vibrating. At very high vibrations, kinetic energy increases. Increasing of kinetic energy, temperatures also will increase. And therefore welding can be done. That's basically the idea. Correct? So here, medical. Have they given medical uses? What is it?
ultrasound
That's all, nothing else.
Ultrasound
Yes.
is used to detect faults in
various applications of ultrasound.
That's all. Okay. Have you heard about kidney stones?
Yeah.
What is a stone? Is there actually a stone inside?
No.
Now then what? So if you are looking at the kidney, these are essential because it helps to remove the waste from the body. And the waste that we are talking about is nothing but urea, right? So this is the urethra which basically takes the urine out, and what happens is sometimes there are fine granules of urea which over a period of time begins to obstruct. Okay, one of course is the actual surgery where you have to cut open and remove those tiny granules. So we call it a stone. But other method is by using sound. So when this is subject to ultrasound, because of the frequencies it begins to move, and those particles are broken down into fine particles and it can be flushed out. Okay, so we have got plenty of uses of ultrasound. So even in the, for example, have you heard about X-rays? For example, X-ray is possible only for if at all you are having a broken bone or something like that. But suppose you want to find out whether the fetus is perfectly all right. Okay, a pregnant woman cannot be exposed to X-rays because it may damage the fetus. You understand? Okay. So in such cases, what is happening is we use ultrasound. So when ultrasound is, person is subjected to ultrasound, it bounces off the fetus and the image of the fetus is given on your computer screen, so you can find out if there is any abnormality. Have you followed? And at the same time, it will not damage the fetus, as the case of X-ray. So medical fields, we are constantly using ultrasound. Understand? So next time when you see some ultrasound somewhere, you should know what is it. Ultrasound, where the frequency is more than 20,000 hertz, and you can use it for various purposes. Is that okay? Right. Let's have a look. Next time, yeah, there are a couple of sums here we can also do here. Why don't we do a couple of them? Today's homework, all of you please write down. There's a worksheet here, page number 82, 83, and multiple choice questions. Page number 82, worksheet, complete the whole thing. And my MCQ, multiple choice question is 84, 85, 84. Basically 84 and 85. This you should be able to do. Okay, but if you do this, then you should be able to conclude with the lesson. Okay? It's almost done.
That's right.
Okay, class. Thank you. Who did not come today?
Oh,
आज 12 है ना?
अरे चलो तुम लोग नहीं आना। भाई मुझे तो घर जाने की बहुत ख्याल होती है मुझे तो रुकना है।